Welcome to our experiment about building a solar hot water heating unit. This was our preliminary test. We built it from a concept, and this was actually proof of concept. This was my original diagram of what I wanted to do for our thermonuclear fusion heat extraction and distribution collector unit, solar hot water heater. Anyway, there was a lot of arguments about the design of this, but my friend Jim, being another Renaissance guy, decided to run with it and began to weld everything up for us. So originally it was supposed to have 16 tubes, and I believe we ended up with 15 total. It wasn't financial, it wasn't conceptual, we really stopped counting. That's all done. That's the brass, nice and shiny copper. Yeah, this is less blurry, so that's a nicer shot. There was a lot of arguments about how the heat would dissipate through it. We now painted it. It's painted flat black because obviously that's what you're supposed to do. There's a bleeder valve there to leave air out of the system once we're filling it. This would be the hot side because heat rises. That would be the cold side. There is no valve on that. However, there is a valve set. That's what I was using as a heat exchanger. It's aluminum coil from an old dehumidifier unit. This is the actual temperature. The left side is the input side. The right one is the output side. So there is a temperature difference. Sitting late afternoon, it was 50-some degrees. And we did see a slight heat change from top to bottom, or from bottom to top. We decided to push forward with the experiment. And there's Jim showing his best side. Sorry, dude. We have a thermometer hooked up on the bottom right. This is, again, late afternoon. It's cloudy. We basically set it up for natural circulation. Cold and hot should just circulate through. And what we discovered, that sitting like this on the lawn, we invented the air conditioner because it actually got colder than the surrounding air. So the next stage was, gee, let's insulate a box and put it inside a box and cover it up so that it retains the heat and doesn't blow through it like a pipe organ. So we made the box. It's a wooden framework with thermal foam backing and sides. Now this is Jim spray painting it. I believe we actually have a video of some sort there.
You want to stand it upright?
What? I'm filming a video.
For some reason it sounds like I have marbles in my mouth. Anyway, that's with the cover laying over it after it's been painted black. Everything has been painted black internally. Jim was very careful. He drilled holes for each screw before we put it in just to protect that. We used a very thin sheet laminate there. It looks frosty because the plastic coating is still on it. And that's it without the plastic coating, sitting up, again, late afternoon because we did all our work late at night. And we charged it up. Now, the thing is, you could do this with PVC, I think, but I wanted to use pressure to see how high a temperature I actually could get. That's our thermometer and pressure unit. And that will show from the output side of it. That's how we leaned everything up. The heat exchanger is in the yellow kitty litter box in the back, and there's a thermometer in there. Now, just in about 15 minutes, it went up to 50 psi, and the temperature on the bottom went to about 115 to 120. We were astounded. Now, a close-up of the thermometer probably would have been a good idea here, but I'm not even aware that we even had these pictures. I thought we were just winging it, which is how we do most of our Renaissance gigs. And that was pretty much it. There's not a whole lot more to say. I will get back and update when we do some more experimenting with it. I haven't really had a chance to work too much with it this summer, but that's what we have, and thank you for watching.